In this video, we will learn how to find out the Marshallian demand function from the given indirect utility using the Roy's identity. The question is, in case of two goods x1 and x2, let the consumer's indirect utility function be. We have the indirect utility function, which is a function of income and price, that is P1, P2 and M, which is equal to M times P1 plus P2 divided by P1 times P2, where symbols have the usual meaning. That means P1 denotes the price of good x1, P2 denotes the price of good x2, and income of the consumer is M. We have to use the Roy's identity to derive the Marshallian demand function for good x1 and x2. Okay, now Roy's identity is a shortcut method of finding out the Marshallian demand function from the given indirect utility function. So Roy's identity simply tells us to find out the Marshallian demand function from the indirect utility function. What we do, we take the ratio of the marginal utility of price change, that is dv upon dp1, the partial derivative of the indirect utility function with respect to price of good 1, upon the marginal utility of money, which is dv upon dm, the partial derivative of indirect utility function with respect to m. Okay, now given this utility function, if I simplify it, so multiply this m to each of these terms, it becomes m times p1 plus m times p2 divided by p1 plus p2. Simplifying further, so we will get m times p1 divided by p1 plus p2 plus m times p2 divided by p1 p2. Okay, here p1 and p1 gets cancelled, so our reduced or simplified indirect utility function will be equal to v is equal to m upon p2 plus m upon p1. Now to find out this dv upon dp1, that is the partial derivative of indirect utility function with respect to p1, we differentiate this function partially with respect to p1. Since m upon p2 is here and we are taking partials with respect to p1, its derivative will be 0. Derivative of m upon p1 will be equal to minus m upon p1 square. Simple thing what we have done it here, its derivative came out like this. So we have m times, if I transpose it to the numerator, it becomes minus 1. Now when we apply the power function rule, we will get minus m times p1 raised power minus 1 by power function rule, and it comes out to be minus m upon p1 square. Okay, when we further solve this symmetrically, to find out the marginal utility of money, we take the partial derivative of the this utility function indirect, which is obviously here, with respect to m. Derivative of m is 1, so we are left with this term. Okay, so p1 plus p2 divided by p1 times p2. Now the Marshallian demand function for good x1 will be equal to the ratio of these things, these partial derivatives, dv upon dp1. So we have minus from the formula, so dv upon dp1 is minus m times p1 square. To this we divide by p1 plus p2 divided by p1 times p2, this thing. Okay, so this is here, this comes like this, and here we have this partial derivative. So here we have m upon p1 square. Now when I transpose it, it gets multiplied by the reciprocated, so this becomes p1 times p2 divided by p1 plus p2. Okay, so p1 square, here we have p1 p1 gets cancelled, so we get x1 comes out to be this very thing, that is x1. The Marshallian demand function for good x1 is m times p2 divided by p1 divided by p1 times p1 plus p2. Symmetrically, we can find out the Marshallian demand function for good x2, which will be equal to the partial derivative of indirect utility function with respect to p2 this time, divided by the partial derivative of indirect utility function with respect to m. Solving this, we will get this as the Marshallian demand function for good x2. I hope I make myself clear in this video and you find out this helpful. Thank you.